Hi everyone. So today we're going to be going through the solutions for tutorial 3. Okay, so let's get started. So for question 1, we were given the velocity v. So v of t was given by t squared minus t minus 6. Okay, and the first part was asking for the displacement. So 1.1. The displacement. Remember that the displacement is just the integral of the velocity with respect to time. So we have the integral from 1 to 4, v of t dt, and this will give us the displacement. So this is equal to the integral from 1 to 4 of t squared minus t minus 6 dt. Okay, so this is easy to integrate. We have 1/3 t cubed minus 1/2 t squared minus 6t, and this is evaluated between 1 and 4. Okay, so we can substitute 4 in place of t. So we're going to have 1/3 4 cubed minus 1/2 4 squared minus 6 times 4. So that's evaluating the antiderivative at the upper bound minus the antiderivative evaluated at the lower bound. So that's going to be 1/3 1 cubed minus 1/2 1 squared minus 6 times 1. Okay, so if you just evaluate all of this together, we're going to end up with a displacement of minus 9/2 meters. Okay, so that's the displacement. Now remember what I said before, don't worry if the displacement is negative. A negative displacement just means that the person or object ended up with a net movement to the left. So we were taking to the right to be positive, to the left to be negative. So this person had a net displacement of 9/2 meters to the left because it's negative. Okay, so the next part was to find the distance traveled. Now remember, there's a difference between distance and displacement. Displacement is your net movement from where you are to where you end up. Distance is the exact length of the path that you took to get from the start to the end. Okay, so they are different. So let's take a look at finding the distance. So this is 1.2. The distance is equal to the integral from 1 to 4 of the absolute value of the velocity with respect to time. Okay, so the absolute value of velocity, remember that was the speed, and the integral of speed gave us the distance. Okay, so this becomes the integral from 1 to 4, the absolute value of t squared minus t minus 6 dt. Okay, so now we have to deal with this absolute value over here. Remember, the absolute value symbol or absolute value function takes the inside argument and returns the positive version of whatever you give it. So to do that with this expression, first we need to find where is it positive, where is it negative, and then reverse where it's negative. So we need to put a minus sign so that it then becomes positive. So notice that t squared minus t minus 6 being less than 0. In other words, we want to know where it's negative so that we can make it positive. So where is it 0? Where is it negative? So we have t plus 2, t minus 3 as its factorization. So if we draw this on a number line, we see that at t is equal to minus 2, it is 0. And at t is equal to 3, it is also 0. Okay, just taking the two factors and making them 0. Now, we notice that this is a happy face parabola because the coefficient of t squared is positive. So that means it's going to be a plus minus plus sort of situation. So we see that on this interval from -2 to 3, it is negative. So that means, well, we're not interested in negative time values. So wherever t is equal to 0, that's our starting point of interest. So we see that from 0 to 3, it's negative. And from 3 onwards, it's positive. So we see that for this first part of the time interval, we need to treat that differently. In other words, we need to put the minus sign in front of the function to make it positive again. Okay, so what we end up with is the following expression for the absolute value. So the absolute value of t squared minus t minus 6 is equal to, we can do this in 2 parts. It's going to be minus t squared plus t plus 6 for 0 less than or equal to t less than or equal to 3. So we had to put the minus sign because it was originally negative. We multiplied by -1 and now it becomes positive. But after 3, it was already positive, so we don't have to do anything. So it's t squared minus t minus 6 as we had it for t greater than or equal to 3. Okay, so we've got the splitting of the function on 2 intervals. So if the function gets split on 2 intervals, then the integral needs to get split on the 2 intervals as well. So what do we have? We have that the integral from 1 to 4, absolute value t squared minus t minus 6 is equal to, we have to integrate the first bit of the function on the first bit of the interval. So that's from 0 to 3, minus t squared plus t plus 6. And then we have to integrate the second bit of the function on the second bit of the interval. So that's from 3 to 4, t squared minus t minus 6 dt. So you see we've got the first bit of the function on the first bit of the interval plus the second bit of the function on the second bit of the interval. Okay, so we have to split it up because of the absolute value function that we have there. So we can do these 2 independently. So the first one is going to be minus 1 over 3 t cubed plus 1/2 t squared plus 6t from 0 to 3 plus 1/3 t cubed minus 1/2 t squared minus 6 times t, but now from 3 to 4. Okay, so now that we've got that, we can substitute the values in and then simplify. Okay, but I'm not going to do that now. That's just fraction work, but you'll see that you will get 61 over 6 meters. And notice how it is positive because we are measuring the positive length of the path that was taken. Okay, so that is the difference between finding the displacement, you just integrate the velocity, finding the distance, you need to integrate the speed or the absolute value of the velocity. Please keep that in mind for the test coming up on Wednesday. Okay, let's look at question 2. So question 2 involved the net change theorem, but now we are applying it to densities. Because remember, if we have a mass density and we integrate it, then we can find the mass. Yeah. So we're given the mass density, rho of x is given by 9 plus 2 root x. And this was kilograms per meter. So it was the linear mass density. So as you move along this metal rod, this is the density that you will find at each point. So if that is the density that you find at each point, if we integrate all of that up, we get the total mass. So the total mass m is equal to the integral from 0 to 4, that's the length of the rod, the density dx. So we have the integral from 0 to 4. Let's just substitute in the density here. So that's 9 plus 2 root x dx. That's equal to the integral from 0 to 4, 9 plus 2x to the 1/2, so that we can use the power rule. This is going to give us 9x plus 2 times, we add 1 to the exponent to make it 3/2, divide by 3/2, that's the same thing as multiplying by 2/3, and then we have x to the 3/2. And this is evaluated between 0 and 4. Okay, if we evaluate this at 0, we're just going to get 0, so that doesn't add anything. So we just need to evaluate this at 4. So this is going to be 9 times 4 plus 4/3, 4 to the power of 3/2. Okay, I won't go through all that working, but you can check for yourself that this is equal to 140/3. And remember that this mass is in kilograms, because the density was kilograms per meter. So this is kilograms. Okay, so if I give you the density and I'll ask you to find the mass, remember that the integral of the density along the length of the rod gives you the mass of the rod. Okay, let's have a look at the indefinite integrals now with the U-substitution. So this is 3.1. So we have the integral of 3x square root 1 plus x squared dx. Okay, so like I said before, there's no set rule with this U-substitution. Figuring out what U needs to be comes with practice. But here we can see we've got the square root of some function inside. So that's a good hint that this inside function should be U. So U is equal to 1 plus x squared. That's good. Now we need to find du. So du is going to be the derivative of that. So we're going to get 2x dx. Okay, but we've got a little bit of a problem here. Our integral has 3x dx. This gives us 2x dx. So we need to fix that. That's easily done. Just a bit of manipulation. So 1/2 du is equal to x dx, but we want 3x dx. So that means 3/2 du is given by 3x dx. Okay, so with all of that done, we can now write out a new integral in terms of u instead of x. So this will be the integral. The square root of 1 plus x squared, that's going to become the square root of u. So the square root of u. 3x dx is now going to become 3/2 du. So we can clean this up a bit. So we have 3/2 on the outside, the integral of u to the 1/2 du. So this gives us 3/2 times. We add 1 to the exponent to make it 3/2. Then we divide by 3/2, but that's the same thing as multiplying by 2/3. U to the 3/2, and don't forget your plus c. Now 3/2 times 2/3, that cancels. We don't need that. But remember, we can't leave it at that because this is in terms of u. What we really want is something in terms of x. So we just put the x expression back and we end up with 1 plus x squared to the 3/2 plus c. Okay, so always remember that last step of substituting back your x expression. You can't leave it in terms of u. Okay, so that's the first example. Let's have a look at the next one. It's 3.2. So we have the integral of 2x cubed sine of x to the 4 plus 1 dx. Again, this inside part here gives us a big hint as to what u should be. So we have the sine of some complicated expression. Let's make that complicated expression u. So u is equal to x to the 4 plus 1. Now we need to find du. So du will be 4x cubed dx. But we don't want 4x cubed because our question had 2x cubed. We've got 4, we want 2, so let's divide both sides by 2. So we're going to have 1/2 du is 2x cubed dx. And now we're happy because we've got the 2x cubed dx, which shows in the expression there. Good. Now let's substitute that into our integral. So we have the integral. Sine of x to the 4 plus 1 just becomes sine of u. And 2x cubed dx now becomes 1/2 du. Good. Now we can take the 1/2 out, and we're just left with the integral of sine. So this becomes 1/2, the integral sine of u du. That's very easy to do. That's going to give us 1 minus 1/2 cos of u. Don't forget your plus c. Okay, but we can't leave it in terms of u. We need to put the original x expression back. So this is going to be minus 1/2 cos of x to the 4 plus 1. And don't forget your plus c, that gets carried down. Okay, so again, very straightforward. You let u be the complicated expression you want to get rid of. You find du. If you need to do some more manipulation, then you go ahead and you do that. And then once all of that is done, you do your substitution or your replacement. So x to the 4 plus 1, that's replaced with u. So sine of x to the 4 plus 1 gets replaced with sine of u. 2x cubed dx, that gets replaced with 1/2 du. Then you do your integral in terms of u, and don't forget to go back to x. Okay, and then that gives us our final answer. Okay, let's take a look at 3.3. So here we have the integral of x square root 1 minus x squared dx. Again, this complicated stuff inside the square root, that gives us the hint at what u should be. So u should be 1 minus x squared. Good. Now we need to find du. So du is going to be minus 2x dx. That's a problem because we have x dx. We don't have minus 2x dx. So let's take the minus 2 over to the other side. So we're going to have minus 1/2 du is equal to x dx. Good. Now we have everything we need. So this becomes the integral. 1 minus x squared, that gets replaced with u. So we have root u. X dx, that gets replaced with minus 1/2 du. Good. So now we can take the minus 1/2 out, and we can rewrite root u with an exponent. So we have minus 1/2, the integral u to the 1/2 du. So now this is pretty easy to do. We add 1 to the exponent, making it 3 over 2. Divide by 3 over 2. That's the same thing as multiplying by 2 over 3. So we have minus 1/2 times 2 over 3 u to the 3 over 2. And don't forget your plus c. Okay. Whenever you have an indefinite integral, you always need to add your plus c. Now, the 2 at the top, 2 at the bottom, we can get rid of that. So we're going to have minus 1/3 u to the 3 over 2 plus c. But we're not done yet. We don't want things in terms of u. We want things in terms of x. So wherever we see a u, we need to replace it with 1 minus x squared. as we had originally. So this is going to be minus 1/3 1 minus x squared to the 3/2. And don't forget your plus c that you need to carry down. Okay, so again, very straightforward. You just need to identify u. That's the complicated bit inside another function, usually. Then you find your du. You do manipulations if necessary to replace whatever's left over with dx. So here we have x dx. That's what we need to get to. And once you've done that, you make your two substitutions, simplify, integrate in terms of u, like we did here. And then don't forget for your last step, wherever you see the u, you need to replace it with the original expression in terms of x. Okay, so I hope this is all making sense. It's really not too bad. You just need some practice, to get used to the whole idea of U-substitution. Okay, I've got a few more to go through. So the next one is 3.4. Sorry, let's change that back. So we have the integral sine of 5x dx. Okay, so we know if this was just sine of x, we could integrate that very easily, but this is sine of 5x. So this 5x is what's making it a bit more difficult than normal. So that tells us what u should be. So u is equal to 5x. du is equal to 5 dx. Okay, got a little problem here because we've got a 5 here, but we only have dx in the original expression. So we need to take that over. So we're going to have 1/5 du is equal to dx. Okay, and that's all we need. So this now becomes the integral. Sine of 5x now becomes sine of u. dx now becomes 1/5 du. Okay, we can take the 1/5 out. And then we're just left with the integral sine of u du. Okay, that's straightforward to do. The integral of sine is minus cos. So we're going to have minus 1/5 cos of u. Don't forget your plus c. And then last step, wherever you see a u, you replace it with the original expression of x. So this is going to be minus 1/5 cos of 5x. And don't forget to carry your c down. Okay, very straightforward, very simple to do. Okay, I've got a few more. Okay, and then we will go on to the definite integral stuff. So next one, 3.5. We have the integral, the square root of 3x plus 2 dx. Again, this inside part here, the 3x plus 2, that's your hint as to what u should be. So u is equal to 3x plus 2. Okay, so typically u is the inside function of whatever you're dealing with. Okay, so we need du. So du is going to be 3 dx. But over here, we just have dx. Over here, we have 3 dx. So we need to take the 3 over. So 1/3 du is equal to dx. Okay, now we're happy because we've got just dx here. Okay, so we've got everything we need to do the integral. So this becomes the integral of 3x plus 2 is replaced with u. So this becomes root u. dx is replaced with 1/3 du. Okay, good. So now we can take the 1/3 out. Integral root u can be replaced with u to the 1/2 du. We add 1 to the exponent to make it 3/2. Divide by 3/2, is the same thing as multiplying by 2 over 3, u to the 3 over 2, and don't forget your plus c. Now, just multiplying the fractions, we get 2 over 9, u to the 3 over 2 plus c. Don't forget your last step. Wherever you see a u, you substitute that back with our original expression in terms of x, which was 3x plus 2. So this is going to be 2 over 9, 3x plus 2 to the 3 over 2 plus c. Again, very straightforward. Okay, so again, yeah, this 3x plus 2, that's making our lives a bit difficult because it's inside the square root. So we let that be u, and then everything else just follows from the steps. Okay, so as long as you follow the steps, then nothing should go wrong. Okay, let's take a look at the next one, 3.6. Here we have the integral of x to the 5 square root of 1 plus x squared dx. Okay, so what should we let be u? Well, we could let it be x to the 5, but that's not really going to get us anywhere because we still have the square root of 1 plus x squared. So we should actually let this inside part be u. Again, knowing to do that just comes with practice. So u is equal to 1 plus x squared. So du is equal to 2x dx. Okay, a bit of a problem here. We've got 2x dx, but the question has x to the 5 dx. How do we get from 2x dx to x to the 5 dx? Well, we can start by taking the 2 over. So we're going to have 1/2 du is equal to x dx. Okay, we're still missing an x to the power 4. That's missing from our expression here. So how can we get x to the power 4 so that we can multiply it by x to get x to the 5? Well, we do that by looking at our expression in terms of u. So if u is equal to 1 plus x squared, then u minus 1 is equal to x squared. But if u minus 1 is equal to x squared, then u minus 1 squared is equal to x to the 4. And that is exactly what we needed. So we're going to take our expression and multiply on the left and on the right by x to the 4. So on the left, we multiply by x to the 4, but we use the expression in terms of u. So it's going to be 1/2 u minus 1 squared du. And on the right-hand side, we multiply by x to the 4. So x to the 1 times x to the 4, that becomes x to the 5. So that would be x to the 5 dx. Okay, so we've got everything that we need there. So let's make the substitution now. So our original expression now becomes x to the 5 dx. That's going to be replaced with 1/2 u minus 1 squared du. I'll save that for the end. And then the square root of 1 plus x squared, that gets replaced with the square root of u. Du. So here we've made all the replacements. So everything is now in terms of u. Yeah, so we need to integrate this now. So this looks not much simpler than what we started with, but notice how we are only dealing with powers. So we've got this u minus 1 squared, we've got root of u. But remember, the square root of u can be written as u to the 1/2. So in fact, we're only dealing with powers here. So let's simplify. So we have 1/2, the integral. Root u can be replaced with u to the 1/2. And then u minus 1 squared we can expand that out using the binomial expansion. So this will be u squared minus 2u plus 1 du. Then we can take this u to the 1/2 and multiply it throughout. So we get u to the 5/2 minus 2u to the 3/2 plus u to the 1/2 du. Okay, then we integrate. So add 1 to the exponent and divide. And then while we're doing that, we can just multiply this 1/2 inside. Okay, so we just do two things in one. So this will be 1/7 u to the 7/2 minus 2/5 u to the 5/2 plus 1/3 u to the 3/2, and then don't forget your plus c. Okay, now we're not done yet. Wherever we see a u, we need to replace it with the original expression in terms of x. That will be 1 plus x squared. So we've got 3 u variables here. Let's replace them with the expression in terms of x. So it's going to be 1 plus x squared to the 7/2 minus 2/5, 1 plus x squared to the 5/2 plus 1/3, again 1 plus x squared to the 3/2, and don't forget your plus c that you need to carry down. Okay, so it looked a bit more complicated, but once you've expanded everything out, you're just using the power rule again. Okay, so actually not much more difficult than what we've had before. Okay, so that's it for the indefinite integrals. Let's take a look at U-substitution with definite integrals. Remember, that just involves one more step of changing the bounds. So let's do that. So 4.1, we have the integral from 0 to 1. Sorry, not from 0 to 1, from 1 to 2 of 1/3 minus 5x, all of that squared, dx. So we proceed as normal. We let u be the complicated part that's making this difficult. So in this case, 3 minus 5x. So u is equal to 3 minus 5x. So du is equal to minus 5 dx. We don't want this minus 5, because over here we just have dx. So we take that over to the other side. We get minus 1/5 du is equal to dx. Okay, but remember, there's one more step we need to do, and that's changing the bounds. So the old lower bound was x equals 1. So that means the new lower bound, u, is 3 minus 5 times 1. That's going to be minus 2. The old upper bound was 2. So that means the new upper bound is 3 minus 5 times 2. So that's minus 7. Okay, so we've got the new expression with u, we've got du, and we've got the new bounds. So let's put all of this together. So this all becomes the integral from minus 2 to minus 7 of 1/3 minus 5x, all of that squared. Remember, 3 minus 5x, we're replacing with u, so that's just going to be 1/u squared. dx is replaced with minus 1/5 du. So we can neaten this up a bit. So we get minus 1/5, the integral from minus 2 to minus 7, u to the minus 2 du. So I just took the u squared to the top so that I can use the power rule in the next step. So we have minus 1/5. The power rule says add 1, which gives us minus 1. Divide by minus 1, so we get a minus u to the minus 1. And we evaluate this from minus 2 to minus 7. Sorry, that's a 7 at the top. Okay, so what are we left with? Minus 1/5. minus u to the minus 1, evaluated at minus 7, is going to be minus 1 over minus 7, minus, and then evaluating this at the lower bound, we're going to get minus 1 over minus 2. So what do we get now? So we're going to get minus 1/5, 1 over 7, minus 1/2. Okay, now simplifying this, we can find a common denominator over here. So this is going to be 1/5. Let's swap these around. So we have 1/2 minus 1/7. We can find a common denominator of 14. So we have 1/5. 7 minus 2 over 14. 7 minus 2 is 5. That's going to cancel with the 5 at the bottom. So we end up with 1 over 14. Okay, so again, very straightforward. The most complicated part of this is probably just the fraction work at the end. Okay, everything else we've done so many times before. Okay, let's look at the next one, 4.2. So this one is the integral from 0 to 1, x e to the minus x squared dx. Okay, so what's making this complicated? Well, it's this exponent here, e to the minus x squared. So let's say that that is going to be u. So u is equal to minus x squared. So du is minus 2x dx. Okay, that's almost what we want. That's almost what we have here. We've got x dx, and here we have minus 2x dx. It's just this minus 2 that's in the way. So let's take that over to the other side. So minus 1/2 du is equal to x dx. Good, that's all the previous steps for indefinite integrals, but now we also need to change the bounds. So if x is equal to 0, then u is also going to be 0. If x is equal to 1, then u is going to be minus 1. Okay, because we've got the minus x squared. So now we've got everything we need to write this integral in terms of u. So this will be the integral from 0 to minus 1, the new lower bound and the new upper bound. E to the minus x squared is just e to the u, and x dx over there is going to be minus 1/2 du. Good. Now we can simplify this a bit. So we can take the minus 1/2 out, and then we have the integral from 0 to minus 1, e to the u du. So this is the easiest integral to do, because the integral of e to the u is just e to the u. So this is minus 1/2 e to the u, 0 to minus 1. So this is going to be minus 1/2 e to the minus 1. That's just e to the minus 1. Can't really make it any simpler than that. E to the 0, that's 1. So we have minus 1. Okay, you can leave it like that if you want, but if you want to take this minus from the minus 1/2 inside, you can swap the terms and we end up with 1 minus e to the minus 1. Okay, just so we don't have so many minus signs lying around. Okay, but this previous line, that's perfectly fine. I don't mind that. Okay, so you see, again, very straightforward. You just need to identify what needs to be u, find du, do any manipulations that you need, change the bounds. That's the important part for definite integrals. And then everything else is straightforward. We've done integration like this many times now. Okay, let's take a look at another one. Next one is 4.3. Just two more to go. So 4.3, we have the integral from 0 to 1 of e to the x plus 1 over e to the x plus x dx. Okay, so this looks really complicated. What do we need to be u? So we kind of stuck now because the top, yeah, we could let that be u. The bottom, we could also let that be u. But the key idea is to let u be this bottom part. Okay, now that seems a bit confusing. Why are we choosing the bottom part? But let's just go with it, and then it will be pretty obvious once we're done. So u is equal to e to the x plus x. So du is going to be e to the x plus 1 dx. You see how after we take the derivative, we get the numerator for free. So we let u be the denominator, and then du becomes all of the stuff at the numerator. Okay, so again, it may look a bit complicated, but just think to yourself, what happens if I let u be the numerator? Well, in that case, I'm just going to get e to the x after the derivative. So that doesn't help us very much. But if I let u be the denominator, then after taking the derivative, I get the numerator for free. So that's much better. Okay, so with this in mind, let's carry on. So we've got u, we've got du. Remember, we also need to change the bounds. So if x is equal to 0, then u is going to be e to the 0 plus 1. Plus 0. Getting ahead here because e to the 0 is 1. Okay, so when x is 0, we have e to the 0 plus 0. But remember, e to the 0 is 1, so we're just left with 1. What happens when x is 1? Well, then u is going to be e to the 1 plus 1. So we can just write that as e plus 1. Okay, so let's put everything together now. So the integral, the old lower bound was 0. The new lower bound is 1. The old upper bound was 1. The new upper bound is e plus 1. Okay, good. Next, 1 over e to the x plus x. Remember, e to the x plus x, that's going to be u. And e to the x plus 1 dx, that's circled in red. All of that is just du. So we just write du. Okay. Now this is much easier than what we had before. So let's do this now. So the integral of 1 over u, that's the natural log of the absolute value of u. Please do not forget the absolute values. That's very important to have. Then we're going from 1 up to e plus 1. So we get the natural log, absolute value, e plus 1, minus the natural log, absolute value of 1. But the natural log of 1, that's going to be 0. So that goes away. So we're just left with the natural log, absolute value, e plus 1. Now we know that e plus 1 is positive. So we can drop the absolute value. So we can just write the natural log of e plus 1. Okay, that's fine. But it doesn't hurt to leave it with the absolute value. Okay, so to be safe, rather leave the absolute value. But if you know that it's always positive, then you can drop it. But there's no harm in leaving it there. Okay, remember that's just for this example where the argument is positive. If the argument was negative, then you have to keep the absolute value there. Okay, or if it could be negative. Okay, in those cases, you have to keep it there. Okay, last question for today, 4.4. So we have the integral from 0 to 1 over 1 plus the square root of x to the power 4 dx. Okay, so now it should be pretty obvious what we need to do here. We need to let u be this inside part, the 1 plus root x. Okay, we don't have much of a choice besides that. Okay, so we let u be this yellow part over here. So u is 1 plus root x. So du is going to be, you can check this with the derivative, but we're going to have 1 over 2 root x dx. Okay, but we don't want that. We just want dx, because that's what's left over here. We've got this other stuff in the way. Okay, so we take the 2x over. So 2 root x du is equal to dx. Okay, but we've got a problem here because on the left-hand side, we have x variables, and on the right-hand side, on the left-hand side, we have x variables mixed with u variables. That's not good. On the right-hand side, we only have x. That's a problem, because we don't want these variables to be clashing. So we need to fix that. So how do we fix that? Well, on the left-hand side, this root x is giving us problems. We don't want root x, we want something in terms of u, because the left-hand side should be u, the right-hand side should be x. Okay, but that's not a problem. If we look back at our original expression, u is equal to 1 plus root x. So u minus 1 is equal to root x. That's exactly what we needed. So we can just do a little bit of replacement here. So 2 root x, we can replace with 2 u minus 1 du, and the right-hand side stays as dx. Now, we fix the problem because the left-hand side is now only u variables. Okay, so that's pretty nice now. So let's do the replacement. So we have the integral, we need to change the bounds. Sorry. So the old bounds was x is equal to 0. So that means u is equal to 1 plus the roots of 0, so that's 1. The old upper bound was x equals 1. So the new upper bound is 1 plus root 1, so that's 2. So we have the integral from 1 to 2 of 1 over 1 plus root x to the 4, that gets replaced with u to the 4. dx, that gets replaced with 2u minus 1 du. Okay, so we can clean this up a bit. So this will be 2 times the integral from 1 to 2 of u minus 1 over u to the 4 du. Okay, so after dividing by u to the 4, this just becomes a very simple power rule. So this will be 2 times the integral from 1 to 2, u over u to the 4, that's going to be u to the minus 3. 1 over u to the 4, that's going to be minus u to the minus 4 du. Now we just do the power rule. We add 1 to the exponent and then divide. So we're going to have 2 into minus 1/2 u to the minus 2 plus 1/3 u to the minus 3. Remember, this needs to be evaluated from 1 to 2. So let's substitute in. So we have 2 minus 1/2, and then 2 to the minus 2, that's going to be 1/4, plus 1/3, 2 to the minus 3, that's going to be 1/8, Now minus, we need to evaluate at the lower bound. It's going to be minus 1/2 plus 1/3. Okay, so now we can just add these fractions all up, find a common denominator, and in the end, you'll see that this is 1/6. Okay, so that's our final answer after adding all the fractions together. Okay, so you'll see not very difficult. Once you identify what U needs to be, everything else is just following the steps or following the algorithm. Okay, if you can remember the steps, you can handle whatever's given to you. Okay, so as always, if you have any questions, please post them on the WhatsApp group or post them, or send me an email. I can help you out that way. And remember that next week, Wednesday, the 9th of March, we have test 1. So that's the proper test 1. I have uploaded the scope. I've uploaded a practice test. Please go through that. Remember, it's 45 marks. You have 1 hour. I encourage you to just spend an hour on Saturday or Sunday. Go over the practice test while timing yourself, okay, just to give you an idea of, what you need to work on for the test. Maybe some parts you're really good at, you'll go through that very quickly. Other parts, you may need some more time. It's good to manage your time with that. Okay. So yeah, please remember those, the quiz that you did and the tutorial test that you did, those were only out of 15. Okay, this one is now out of 45. Okay, so it's a bit more to do. Okay, so please, effective time management, it's very important. And then after the 1 hour that you have to write the test, you will then have half an hour to scan your work and upload it. Okay, please make sure that everything is uploaded. If you're uploading a PDF, make sure all the pages are there. If you're uploading pictures, make sure all your pictures are there, because after the cutoff, that is it. You cannot upload anymore. Okay, but yeah, if you have any questions, please just let me know. And also Monday and Tuesday, those will be revision. Okay, so we'll use that for revision, and then Wednesday you write. Okay, bye everyone, and please contact me if you need any help.